Tracing an algorithm is simply put going through the steps in the algorithm to generate a result, usually starting with an input. We follow each step until the algorithm ends. Tracing an algorithm is a good practice to test the algorithm's consistency and to spot errors or lapses. A table, which includes the steps, inputs, variables, and output, is used to trace an algorithm.
What is algorithm? An algorithm is a finite sequence of well-defined steps to perform some task such that each step is a clear instruction that can be done in a finite amount of time. The sequence in which the steps are done is clear and the process is guaranteed to stop after a finite number of steps have been done.
Tracing an algorithm is important because it allows us to understand the flow of instructions, check if the algorithm works properly, detect logical mistakes early, and observe how variables change during execution.
Programmers often create a trace table. A trace table records the step number, input values, conditions evaluated, and the final output. This method makes complex algorithms easier to understand.
Let us now discuss the example 1. The problem is to determine whether a student pass or fail based on their score. The algorithm follows these steps. 1. Input the student's score x. 2. Check if x is greater than equals to 60. 3. If the condition is true, the output is pass. 4. Otherwise, the output is failed. In this example of a decision-making algorithm, because it chooses between two possible results.
Let us trace the algorithm using the score 75. The algorithm receives input value 75. It checks the condition x greater than or equal to 60. Since 75 is greater than 60, the condition becomes true. The algorithm outputs pass. Tracing allows us to clearly see how the decision was made.
Now, let us test another input value. Input value is 50. The algorithm evaluates the condition. Because 50 is less than 60, the condition becomes false. The program executes the else statement and outputs failed. This example shows that algorithm responds differently depending on the input provided.
This algorithm uses iteration, also called looping. Iteration means repeating a process several times until a condition is satisfied. Instead of manually checking every number, the algorithm automatically compares values one by one. This method is efficient when working with large amount of data, given set 5, 4, 8, and 3. Initial assumptions, minimum equals 5.
Next is we will be tackling using a table using the trace example 2. So in this table, the first step, the minimum is assumed as 5 in iteration 1. The first value it sets is 5 since it is the first minimum value it sees. The next step, compare, the minimum value is set to 4. The second iteration, because the next number it compares is 4 to 5. So it sets 4 as the minimum value. It does this for 2 more times until it sees the last variable. It compares 3 to 4 and then updates the minimum to 3. So the final output on the fourth iteration is the minimum value is 3 and the final output is also 3.
To conclude, tracing an algorithm is an essential technique in programming and problem solving. It helps us understand how algorithm works step by step, monitor how variables change, detect logical errors, and verify correct outputs before coding.
By practicing tracing, students develop stronger computational thinking and logical reasoning skill.
Tracing transforms abstract instructions into clear and understandable process.